Alright, in this video we're going to finish up the solving linear equations notes. So we're on the second page now. On this page we're going to look at multi-step equations. So on the first page everything was a one-step equation. So if you have multiple steps, what we have are some guidelines. They're not really rules because you don't have to follow these in exactly the order that they're given. So we're going to call these guidelines. The only rule is that equal actions principle. If you do something to one side of the equation, you have to do the same thing to the other. But it's more efficient sometimes to follow these steps. So step one, or the first one I'm going to put on there, is if you have parentheses, it's a good idea to get rid of those. Now by parentheses, I'm talking about something like number 15, where you've got more than one term inside your parentheses. I'm not talking about parentheses that just indicate multiplication. So we're going to use what's called the distributive property to rewrite those. So once that's done, there's what I call a cleanup step. And so we're going to clean up each side, and we do this by combining like terms. So these first two steps are basically just rewriting generally one side of the equation. So kind of cleaning it up and getting something that's equivalent to make it a little bit easier to work with. And then our next step is probably one you're familiar with. I'm going to put all x's on one side and all constants on the other. Now, you don't necessarily have x every time, but I just picked x, as a general letter. Okay, so everything that has an x goes on one side of the equation, everything that doesn't have an x goes on the other, and then divide by the coefficient. So in the first couple of examples, I'll show you maybe two different ways to solve the equation, and neither of them are right or wrong, but maybe one's easier than the other. So if we look at number 13, remember this is negative 2 times x plus 4 equals 58. I don't have any parentheses, and I don't have any similar terms. So notice this one has an x and this one doesn't, so those two can't be combined. So I'm really starting with step 3. I want everything that has an x on one side and everything that doesn't have an x on the other. So what I'd like to do is I'd like to get this plus 4 and I'd like to get it moved over. So I can do that. I can get rid of the plus 4 by minusing 4 on both sides. So we know those will zero out. And I get negative 2x equals 54. Then my last step, I'm going to divide by the coefficient, which is negative 2. Okay, those make 1, so that just leaves me with 1x, or x. And I get x equals 54 divided by negative 2, which is negative 27. So I'm going to show you another way you could have done it. So this is also an option. Let's say that you took the equation and you decided to get rid of the negative 2 first. So you said, okay, I know that's a coefficient, so I have to divide by negative 2. If you do that, you have to divide everything in the equation by negative 2. Okay, so there's that equal action idea. So you end up with x minus 2 equals negative 29. And then your last step would be to get rid of the minus 2, so you would add 2 to both sides and you would get x equals negative 27. So this is a legitimate way to do the problem. Maybe not the way most of us think, so we switched a couple of steps, right? We divided and then we did our add and subtract. So we sort of switched it, but it works the same either way. All right, so let's try number 14. 3 times x minus 4 equals 13. So if I do this one the same way I did number 13, I don't have parentheses, I don't have similar terms, so I want to put all the x's on one side, which means I want this minus 4 to go away. So I do that by adding 4 to both sides, and I end up with 3x equals 17. And my last step is to divide by the coefficient, And this doesn't come out pretty. So we have some options. 17 over 3 is a perfectly acceptable answer. You can change it into a mixed number. So figure out how many times 3 goes into 17. And then I take the remainder and put it back over the 3. So you could also put 5 2/3. You don't have to take this last step. 17 over 3 is perfectly good for an algebra answer. All right, so on the first one I showed you another way to do the problem. So let's look at this. This is an option, maybe not a good option, but it's an option. So let's say I started with division. Okay, so I said, all right, I want to get rid of that 3. So I'm going to divide by 3 all the way across. And I get x minus 4/3 equals 13/3. All right, so that's not terrible. I mean, I'm working with fractions, but now I want to get x by itself, so I would add 4/3. And I get x equals 4. Oops, let me redo that. This is what happens when you work with fractions, right? You start messing up. All right, so I'm going to write this down. I end up with the 13/3 plus the 4/3. We haven't talked about fractions yet, but I know if the denominator's the same, I add the top, I keep the bottom, and we can see that that is the same answer as the one over here. So maybe not the best option, but you can do it that way. All right, so with number 15, we're going to start getting into ones that use more of the steps. So remember, our first step is to remove parentheses. So we're going to use what's called the distributive property. So I find my parentheses and I find the number that's in front of them. So in this case, it's a -3. So I'm going to distribute not just the 3, but also the negative. So I'm going to rewrite the left side. I'm going to rewrite the 6. And when I get over here, -3 times x is -3x. -3 times +1 is a negative or a -3. Okay, so you do have to have a minus in there. All right, so I got rid of my parentheses. So here's the cleanup step. If you take a look at the left side, I've got a constant and I've got a term with x. So those can't be put together. But on the right side, I have 2 constants. So I have a 6 minus 3, and I can certainly put those together. Now, because they're on the same side, I'm not using my addition principle. I'm just saying 6 minus 3 is going to be 3. So I'm combining or cleaning up just that one side. Okay, so these two are equivalent to each other. Now, once I get to here, I want to put all the x's on one side and all the numbers on the other. So let's say I want to put my x's on the left. That means I want to get rid of this minus 3x. So I'm moving the whole term. So here I use addition. Okay, and these are similar, so I line those up. Now, I was trying to make that one go away, and I did, but notice I accidentally made that one go away also. So this is kind of a special case. If your x's drop out and you're left with a false statement, that means that there's not a solution to this equation. So it doesn't matter what you pick for x, you're never going to get the two sides to come out to be the same. All right, so let's try 16. Notice I don't know if y'all can hear that, but my cat is chewing on a cardboard box right next to me. Stop. Stop. All right, sorry, you guys are going to hear my cats a lot in these videos. All right, so this one I'm going to distribute a +3. Okay, so I'm going to keep that left side. I'm going to rewrite it. And then I keep the 7, so I'm going to have +3 times x. That's going to be +3x. A +3 times a -9 is a -27. So just like the last problem, once I get rid of my parentheses, I can look for anything I can clean up. So the left side, I don't have similar terms, but over here, notice I've got 2 constants again. So I want to do the 7 minus 27. Okay, so the left side stays the same. It doesn't matter what order you put these in. I might put the 3x first, and then 7 minus 27. The signs are different, so I subtract and keep the sign on the 27. So I get 3x minus 20. All right, so I've removed parentheses, I've cleaned up each side. Now I want to get all my x's on one side. I tend to put them on the left, although you can put them on either side. So I want my x's over here, so I want that 3x to go away. I'm going to minus 3x to both sides. They cancel here, and I get 14 plus 2x, so I do the 5 minus 3. And be careful here, you need to bring down that negative, so you're left with a minus 20. All right, I got x's on the left. Now I want to get constants on the right. I want the 14 to go away, so I'm going to subtract 14 to both sides. I get 2x equals. Now these are both negative, so I'm going to add them and keep the sign, and I get negative 34. All right, last step is to divide by the coefficient, and I end up with x equals negative 17. All right, so the equations are getting a little bit longer as we go. All right, so let's look at our last two. This one I see parentheses and I just see a minus. I don't see a number there. That really means you're distributing a minus 1. So if you want to write the 1 in there, it's not a bad idea. And that's going to distribute, and I need to do that first. So we have 6x. Negative 1 times 2x is negative 2x. Negative 1 times negative 9 is positive 9. And then I bring down the rest of the problem. All right, so my next step is my cleanup step. I'm looking at one side of the equation at a time, and I'm noticing on the left I've got a couple of x terms. So I want to go ahead and clean that up. It's on the same side, so I'm not using my addition principle. I'm just saying 6 minus 2 is 4. So that becomes 4x plus 9 equals 12 plus x. All right, let's get all our x's on the same side. I tend to put them on the left. I want this x to go away, so I minus x to both sides. So 4x minus 1x gives me 3x. I bring down the plus 9 and I bring down the 12. All right, now I want to get my constants on the other side, so I'm going to minus 9 to both sides. I get 3x equals 3. And then finally I divide by the coefficient, and 3 divided by 3 gives me 1. All right, so that one used pretty much all the steps that we had. All right, let's look at our last one. You'll notice that there's no parentheses on this one. So I want to look at my cleanup step. On the left, I've got an x term and a constant. Those cannot be put together. But on the right side, I have an x term and 2 constants. So I can go ahead and figure out what 6 minus 10 is. Okay, so recopy the left side. 6 minus 10 is negative 4. Doesn't matter what order you put that in. I might bring the x down first. So notice I've got to bring down that minus. And then 6 minus 10 gives me the minus 4. All right, so now x is on one side, numbers on the other. I like to put my x's on the left, so I want to get rid of that minus 3x. So I'm going to add 3x. I get 8x minus 4 equals negative 4. Don't forget to bring that negative down. So now I want constants on the other side, so to get rid of the minus 4, I add 4. And I end up with 8x. Those cancel. Now over here I've got to put something. So a negative 4 and a positive 4 gives me a 0. All right, so our very last step is to divide by 8. So I end up with x equals 0 divided by 8. Now if you check in a calculator, if you do 8 divided by 0, if you switch that, you'll get an error. You can't divide by 0. But if 0 is on the top, the answer is just 0. All right, and that is a perfectly acceptable answer for an equation. If I checked it and plugged it back in, I would end up getting negative 4 equals negative 4, which would be a true statement.